Good morning, children. In previous class, we learned the effect of change of temperature on interconversion of states of matter. Okay, in today's class, we will learn effect of change of pressure on interconversion of states of matter. Okay, first we will study interconversion of or conversion of gas into liquid. Okay, we will take a cylinder. This cylinder is filled with gaseous molecules. Okay, we will take a piston. This is piston, movable piston. We will apply some pressure. We observe that let me draw. Okay, see here. Take a cylinder. In this cylinder, gas is filled. Okay, gaseous molecules there. By using piston, we are applying the pressure. Okay, as we apply the pressure, the intermolecular space. Okay, this intermolecular space between these gaseous molecules will decrease, and these gaseous molecules will move closer. Okay, see here in this diagram, here these gaseous molecules, they are moved close. Okay, further if we apply pressure, if we apply more pressure, again here the intermolecular space, okay, this is further decreased, and these gaseous molecules will occupy small volume. See here, they will occupy the small space as compared to this. Okay, like this, on increasing the pressure, the intermolecular space between gaseous particles decreases. As a result of decrease in intermolecular space between gaseous particles, gaseous particles moves closer, and intermolecular force of attraction increases. As a result, gaseous molecules are converted into liquid. Okay, So on increasing the pressure, the intermolecular space between gaseous particles decreases. As the intermolecular space between gaseous particles decreases, these gaseous particles moves closer, and as they move closer, intermolecular force of attraction between these gaseous particles will increase. As a result, okay, like gas is converted into liquid. Okay, to convert gas into liquid, we need to apply more pressure. Okay, high pressure is applied, or we have to decrease the temperature. Okay, we will learn two terms, that is critical temperature. Okay, critical temperature means the minimum temperature above which gas cannot be liquefied is called critical temperature. Okay, next we will see critical pressure. Okay, the minimum pressure which is required to liquefy a gas at critical temperature is called critical pressure. Okay, see here, that is the process of conversion of gaseous particles into, or the process of conversion of gas into liquid, okay, by decreasing the temperature or by increasing the pressure is called as liquefaction. Okay, liquefaction, we will study this first. Liquefaction or liquefaction. Liquefaction of gas. Okay, liquefaction of gas, it is the process of conversion of gas into liquid by applying high pressure or by decreasing or lowering the temperature. Okay, this process is known as liquefaction of gas. And see here, critical temperature, it is the minimum temperature above which gas cannot be liquefied is called critical temperature. And one more, that is critical pressure, the minimum pressure which is required to liquefy a gas at critical temperature is called critical pressure. Okay. Okay children, see here, states of matter interconvertible. See here, this is solid, liquid, gas. Okay, to convert they are interconvertible, therefore here I am writing double. Okay, like this. Here solid can be converted into liquid by increasing temperature. By increasing temperature. Okay, on heating this solid can be converted into liquid. Whenever heating is carried out, okay, heating is done, obviously temperature will increase. Okay, so to convert solid into liquid, okay, solid into liquid, we have to heat. Again this liquid is converted into gas by increasing the temperature. Okay, reverse we can convert this gas into liquid by decreasing the temperature. Here also same, by decreasing the temperature liquid is converted into solid, or we can also say by increasing or applying high pressure we can convert gas into liquid and again liquid into solid. Okay, we can also convert this gas into solid, okay, by applying high pressure. Okay, see here, therefore the states of matter are interconvertible. This is solid, liquid, this is gas. So they are interconvertible. Okay, children, now we will study this is all about the effect of pressure. Okay, effect of pressure, effect of change of pressure on interconversion of states of matter. Now we will study evaporation. Now we will study evaporation. Evaporation, it is the process of conversion of surface liquid particles into vapor particles at any temperature on its own. Okay, liquid is converted into vapor at any temperature. Okay, this process is known as vaporization. Okay, the process of conversion of liquid into vapor on its own at any temperature is known as evaporation is known as evaporation. Okay, here you might have observed that whenever a nail polish remover is kept in open air, okay, its molecules, nail polish remover molecules, gets evaporated on its own. Okay, the process of conversion of liquid into vapor on its own at any temperature without heating. Here liquid is converted into vapor. Therefore it is the process of conversion of liquid into vapor on its own at any temperature. There is no specific temperature for the evaporation. Evaporation takes place at any temperature. Okay, here in evaporation, surface molecules, surface liquid molecules are converted into vapor. Okay, therefore this evaporation is a surface phenomenon. Okay, see here, if you take a water inside the beaker and you keep this water in an open ground, okay, after some time you will observe that level of the water inside this beaker will be decreased, because here the water molecules are converted into vapor. Okay, this is water, the water molecules present on the surface of the water. Okay, they are having, these water molecules there which are present at the surface of this water, okay, they are converted into vapor. Only surface molecules are converting into vapor. Therefore this evaporation is known as, evaporation is a surface phenomenon. Only surface molecules, surface water molecules are converting into vapors, because they are having less intermolecular force of attraction compared to the bulk particles. Okay, see here. So therefore these surface molecules gets evaporated at any temperature without heating. Okay, therefore it is a surface phenomenon. But boiling is, if you see boiling, what happens in boiling? If water is taken in beaker and it is boiled, or it is heated, okay, on heating, here the bulk particles, okay, here bulk particles, these bulk water particles are evaporated. Okay, vapor molecules will move from bulk, or we can also say that bulk water particles, the water particles which are present inside the water, but not these surface particles. Okay, not this surface particles, but the water particles, bulk water particles will evaporate in case of boiling. Okay, boiling is different from evaporation. Okay, that also we will see. Actually, we will compare evaporation and boiling. Okay, actually this evaporation occurs on its own at any temperature. At any temperature, evaporation occurs on its own at any temperature, but boiling occurs only at a particular temperature. at a particular temperature. Next, second difference is evaporation is a surface phenomenon. Evaporation is a surface phenomenon, that is, it takes place, evaporation takes place only from the surface of the liquid. Only from the surface of the liquid. Whereas this boiling is bulk phenomenon. Boiling is a bulk phenomenon. That is, it involves formation of vapors from the entire liquid, but not surface of the liquid, but not from the surface of the liquid. Here this boiling is a bulk phenomenon, that is, it involves formation of vapor from the entire liquid. Okay, from this entire liquid, formation of vapor takes place. But in case of evaporation, only surface molecules are evaporated. Okay, therefore it is a surface phenomenon, whereas boiling is a bulk phenomenon, because here the entire water molecules except this bulk, okay, this bulk molecules are evaporated. Okay, last difference is evaporation causes cooling effect. Whereas this boiling does not cause cooling effect. Then what is cooling effect? We will study in next class. Okay, now we will see the evaporation, factors affecting the evaporation. Now we will see factors affecting the evaporation. There are 5 factors which are affecting the evaporation. We will study one by one. First factor is surface area of the liquid, or surface area. Okay, greater the surface area, greater will be evaporation. Greater will be evaporation rate. Okay, see here, this is a small plate. In this I am placing some water. Okay, next we'll take one beaker. In this beaker also we are placing water, same volume of water we will place. Okay, if you compare these two, plate and beaker, this is beaker. Among these two, evaporation takes place more from this plate. Okay, the water present in the plate gets evaporated more than that of the beaker, because here in plate the surface area is more, therefore here evaporation is more, rate of evaporation is greater than that when we compare with this beaker. Okay, inside this beaker, here the surface area is less compared to this beaker, sorry, this plate, therefore here the evaporation is less compared to this. We know that this evaporation is a surface phenomenon. Okay, evaporation is a surface phenomenon, since the liquid particles which are present at the surface are converted into vapors. Okay, they are converted into vapors. Therefore, with increase in the surface area or greater the surface area, greater will be evaporation rate. This is because the only particles on the surface of the liquid get converted into vapors. So as long as, okay, as greater the surface area, greater will be evaporation rate. We will see next factor, that is increase in temperature. Children, already we know that on increasing temperature, kinetic energy of the particles increases. Okay, as the kinetic energy of the particle increases, intermolecular force of attraction between liquid particles decreases. As a result, particles are easily converted into vapors. Okay, see here. This is a beaker. Here particles are present. This is a liquid. When temperature increases, these particles will gain some energy and their kinetic energy decreases. When kinetic energy decreases, they will easily overcome the intermolecular force of attraction. Okay, they will easily overcome the intermolecular force of attraction. As a result, these liquid particles can be easily converted into vapor. Therefore, with increase in temperature will increase rate of evaporation. Okay. This is second factor. Now we will study third factor, that is increase in the speed of wind. Increase in the speed of wind. Okay, see here. This is a cup. Inside this we have kept tea. It is a teacup. Inside this tea is there. So it is hot tea. Since it is hot here, this vapors of the water are continuously moving. Okay, if you place this cup in front of a fan, this is fan. Okay, as the wind blows, the vapors above this cup will blow or will move along with this wind. Okay, as these vapors will move along with the wind, again this conversion of liquid into vapor takes place. For continuously this takes place. Okay, so new vapors from this liquid are as this. Okay, we will take a I will repeat it once again. We will take a teacup, and in that we will keep hot tea, and this cup is kept in front of a fan. Okay, we will switch on the fan. As we switch on the fan, wind blows. Okay, here above this teacup there are vapors of water. Okay, since this is hot, here the liquid is converted into vapors. Okay, the water here, whatever it is present in tea, is converted into vapor. When fan is switched on, wind blows. Along with this wind, these vapors will move in forward direction. Okay, again as these vapors will move in forward direction, again new vapor molecules are formed here, or new vapor molecules will move from here to here. Liquid is converted into vapor molecules. Okay, this process continues as long as wind blows. Okay, so from this we can understand that with increase in speed of wind, evaporation process also increases, because continuously vapors are taken away from the wind. Okay, therefore increase in speed of wind increases the evaporation rate. Increase in speed of wind increases evaporation rate. Okay, because as the vapors are formed, above liquid, okay, as wind blows, those vapors are taken away, by wind, by blowing wind. As a result, new vapors are formed above the liquid. Okay, as this process continues, okay, new vapors are formed. Again these vapors are taken by this wind. As the wind continuously blowing, this wind will take the vapor particles which are formed above the liquid. Okay, as this process continues, with the increase in the speed of the wind, there is a increase in evaporation rate. Okay, this is what third factor. Now we will see fourth factor. Fourth factor is decrease in humidity. Okay, first we will see what is humidity. Humidity is the minimum amount of water vapor present in air is known as humidity. Okay, the minimum amount of water vapor present in air is known as humidity. Okay, see here, actually in rainy season humidity is more. Okay, since in rainy season there will be continuous raining, as a result more amount of water vapor is present in air. Okay, more amount of water vapor is present in air. If you see in summer season humidity is less compared to the rainy season. Humidity is less. Okay, actually what happens, this decrease in humidity, if the humidity decreases in air, then evaporation rate increases. Okay, see here, in summer season, I told that in summer season humidity is less. As a result, rate of evaporation increases. If you observe level of water in ponds in rainy season and in summer season, in rainy season actually the ponds are completely filled. Okay, but when you observe in summer season, level of the water in ponds or rivers will decrease. Why it decreases? Because in rainy season there is a humidity is more. Okay, humidity is more. Because of the more humidity, water vapor cannot evaporate. Okay, water vapor, the rate of evaporation is less. Okay, but in summer season, since humidity in the air is less, as a result rate of evaporation increases. As a result, the level of the water in ponds also decreases. Okay, that's why whenever you try to dry the clothes in rainy season, okay, whenever you try to dry the clothes in rainy season, they will not dry easily, because since in rainy season that air humidity is great, humidity is more. Okay, because of the humidity is more in air, this water which is present in this cloths can't be evaporated, and it is not converted into water vapor, and it cannot move with the air. But you see in summer season, okay, if you try to dry the clothes in summer season, they will dry within 1 hour, because in summer season the humidity is less in air. As a result, more and more water molecules will evaporate and the clothes will dry easily as compared to the rainy season. Therefore, with decrease in humidity, evaporation rate increases. Okay, now we will learn last factor, that is nature of liquid. Nature of liquid. This evaporation also depends on is also affected by the nature of liquid. Okay, if you place water in an open glass, if you place water in one glass and glycerin or nail polish remover in another glass. Okay, if you place this water in one glass and nail polish remover in another glass, and you will place same volume of the water and nail polish remover. Okay, after some time you observe, okay, nail polish remover gets evaporated. It gets evaporated easily than this water, because here this nature of liquid, nail polish remover, okay, it is a liquid. This nature of liquid is different from this water. Okay, therefore this evaporation, rate of evaporation also depends on the nature of liquid. The liquids which is having lesser boiling point, the liquids which are having lesser boiling point will have more tendency to evaporate. The liquids which are having lesser boiling points will have more tendency to evaporate. Okay, in short we can also say that liquids with lower boiling point will have greater evaporation rate. Okay, this rate of evaporation also depends on the nature of the liquid. Okay, the liquid with lower boiling point will have more tendency to evaporate, or it is having greater evaporation rate. The liquids with higher boiling point, okay, they will have lower evaporation rate. Okay, observe here water. Okay, what is the boiling point of water? 100 degrees Celsius, whereas this nail polish remover, its boiling point is less than 100 degrees Celsius. Therefore, this nail polish remover will evaporate first, okay, then that of this water, because water is having 100 degrees Celsius, whereas this nail polish remover boiling point, okay, boiling point is less than 100 degrees Celsius. Therefore, this nail polish remover have more tendency to evaporate than that of the water. Okay, so these are the 5 factors affecting the rate of evaporation. First factor is surface area. Greater the surface area, greater will be evaporation. Second factor is increasing temperature. Increasing temperature increases the rate of evaporation. And third factor is increase in speed of wind. Increase in speed of wind increases the rate of evaporation. And that fourth factor is decrease in humidity. Decrease in humidity will increase the rate of evaporation. Whereas this last factor, nature of liquid. Okay, liquids with lower boiling point will have greater evaporation rate, whereas that liquid with higher boiling point will have lower evaporation rate. Okay, children, these are the 5 factors affecting the rate of evaporation. In next class we will learn cooling effect. Okay.